Assalamu alaikum. Hi everyone. I hope that you are enjoying the time. Today we have another interesting class, and in today's lecture we would focus on three different things. We would focus on something called soil particle density, and we would know what it is and how it affects the soil. And also we're going to learn about the soil bulk density and how can we determine it, and what is the relation between bulk density and compaction. And then we're going to end the lecture with the bulk density and the pore spaces. So what happens when the soil gets compacted? What happens exactly to the pore spaces? So without further ado, let's start the lecture.
Now, before diving into the details of today's lecture, let's have a moment of think. Now, look at the picture to the left corner, top left corner, and tell me, what do you see? Think about it for a while. All right, I think this is enough time for you to think. Well, basically we can see from the picture that there is some areas where there are vegetation, like it's covered with grass, and there are some patches, some areas where there is no vegetation, and not only that, the water only bonds on that particular place. Now, why does these things happen? What is the cause of that things? And what is the relation between soil, water, vegetation, and those patchy, and vegetated areas? Well, let's see the story. Well, basically this is a picture which have been taken from a savanna in Africa. And what you can see that most of the area is covered with grass. However, there was a truck which was driven through the field, and in that particular area where the truck was driven, you can see there is no vegetation, and it is clearly that the signature of the tires is already there. Now, what happens when this happened? Well, basically when the truck was driven on the soil, it compacted the soil and also it removed the vegetation because of the continuous driving in that area. And because of this, water was bonded on that particular area. Now, I want you to remember from the previous lecture that vegetation can open up the soil, like create baths in the soil, and that allows water to go in to infiltrate. But what happens now that, as you see from the second picture, that with the compaction, or when the truck was driven on the field, it basically compacted the soil, pressing it and removing the vegetation. And by this, you reduced further the water movement, as you can see from the arrows, comparing the normal soil and the compacted soil. And not only that, the damage can be really devastating and can affect many other soil functions. You would know these details after you finish the lecture. So, now one of the fundamental things that I want you to keep in mind, that when we think about soil, we would find that it basically consists of three different components. Soil, the solid particles, which are the particles, and then you have the organic matters, and finally you have the pore spaces, which can be occupied by water entirely or filled with air, or it can be partially filled with air and water. Now, what if we want to quantify these three things? What can we do? Well, basically you can quantify them in a mass based, by which you just weigh these components. Then the total mass of the soil will be basically the mass of the soil, ms, plus the mass of water, mw, plus the mass of air. And you would find that the mass of air is almost negligible, like it's almost zero. Now, if you want to do this in a volume basis, then it's the same concept. The total volume of the soil is basically the volume of the solids plus the volume of water and the volume of air. Now, we know how to do the mass, but how can we measure the volume of the soil? Well, basically, we would use the same concept. Now, if you want to measure the volume of water, what you would do? You would take a graduated cylinder that is graduated, indicated with the levels, and then you put the water there and you can do it. In soil, there are different techniques, but you can imagine the concept like this. So you would be able to quantify the mass and also the volume of the soil. Now, why these two concepts are very important here? You would know later on because we would use them for certain calculations. So keep them in mind. All right, now we can start with the first part of this lecture, the particle density of the soil. Now, to understand the concept of soil particle density, I want you a little bit to pause and underline the term density. And try to remember from your background information, what is density? What is the equation of density? You would see that density is basically the mass over the volume of that things. So the soil particle density is exactly the same concept. You basically measure the mass of the particles, only the particles, and divide it over the volume of the particles. Now, to understand this and to imagine, look at the pictures. You would see that we know that the soil particles can be sand, silt, or clay. But we also know that in the soil, you always have the pore spaces and you have the organic matter. So to measure the particle density, you should exclude the other two things. You should exclude the pore spaces and you should exclude also the organic matter. And you only deal with the solid. Now, to conceptualize this and make it simple, let's imagine that you have a fixed volume. And this volume is basically a cube. Now, the volume we can determine the volume of this cube by multiplying the area of one face times the 6 faces that you have, and that would give you the volume. Now, to calculate the particle density, then we have to assume that we will put all the particles, compress it in this shape to form this cube. And then it's without air, without organic matter, it's only the particles. And then you weigh it and you divide it by the volume of this cube, which is 1 cubic meter. And then you get the particle density. Now you would see that the unit of the particle density is basically can be expressed as megagram per meter cube, or it is the same as gram per centimeter cube, just conversion. And you would see that the particle density of the soil can vary between 2.6 to 2.75 gram per centimeter cube. Now, why this variation? And we only deal with the same thing, with soil. To understand this now, again, go back to the concept of cube. Now imagine you have this cube and it is only filled with quartz. And then imagine you have another cube which is only filled with gold. Now, which one of them would have a higher particle density? Think about it. It's of course the one which have a higher mass because our volume is fixed. Now, which one is heavier, quartz or gold? You know, especially the ladies, you know, the gold is very light. So basically the quartz are heavier. Now we can see that the difference between them is basically lie on the chemical properties of that particular mineral which form the particles. So if you have a mineral that is denser and heavier, then you would end up with a higher particle density compared to a lighter type of minerals like gold. That's why the particle density depends on the chemical properties of the mineral, but it is not influenced by the particle size. Regardless of the size, when you put them all together to form that particular volume, then it is the same value. And it is also not influenced by the arrangement of the solid particles. Why? Because now we are dealing only with the particles. All of this volume cube is 100% occupied with particles. There is no space, there is no organic matter, nothing. So it's incompressible. And that's why it is also not affected by the cultural practices like, for example, blowing the farms or adding vegetation or anything, because all of these effects will be excluded and you will only deal with the mass of the particles and the volume of the particles. Now, how can we quantify the particle density in the lab. Let's assume that I want to know the exact value of the particle density of the two examples that I use. For a particle made of quartz and another particle made of gold, they are all in the same shape, in the same size, everything is the same, except they are different in terms of the chemical properties. One is gold and the other one is quartz. Now, how to do it? Remember, the particle density is basically the mass of the particles divided by the volume of that particle. Now, the mass is easily determined. We can get a balance and we put the first particle, the quartz, we get the mass. Then also we weigh the other particle, which is the quartz, and we get the mass. Now we get the mass of the gold, we get the mass of the quartz. But the volume, how to deal with it? Now, as you can see from the picture, the size or the shape of the particles might not be even, like in a regular shape. It is irregular in shape, so we cannot use mathematics to do that. So how can we determine the volume? Simple. You get a volumetric cylinder, you get a graduated cylinder, you fill it with water, and you can see now the level is just 30 ml. Now, once you put the first particle, which is the quartz, on the water, it will sink, and as it sinks down in the water, it will displace the water. So the level of water, as you see in the picture, changed from 30 to 35. And then you just subtract 35 minus 30, and that would be 5 ml. And then you just divide the mass of the quartz divided by the volume displaced, and that would be the particle density. Now, when you do the same process for the gold, the displacement, because the gold is lighter in weight, it will be less. That's why then the particle density of the gold will be less than the quartz. Now, what is the difference between particle density and bulk density? The difference is very easy. When we dealt with the particle density, we said that we ignored organic matter and the pore spaces. But in real life, in your soil, if you are dealing with the soil as a whole, pore spaces and organic matter always exist in the soil. Or maybe you might have less organic matter, but pore spaces is always there. And the pore spaces can be filled with air or water. Now, imagine the same thing, that we have cube, and this cube is made of soil. We can know the volume of this cube because we know that we can calculate the area and multiply it times the number of faces, and we get the volume, which is 1 cubic meter. But how to get the mass? Again, we weigh this cube, and we keep in mind that this time we don't have 100% particles, but we are dealing with the whole soil, including its organic matter and the pore spaces. That's why the mass will be much less, and that's why your bulk density will be much less. It's the same thing, mass over volume, but here we should include the pore spaces and the organic matter. That's why most of the soils, or the range of the bulk density of the dry soil, ranges from 0.6 to 1.6, but it can vary between one soil to another soil. Why? Because remember, each soil would have a different size of the particles, and different also, maybe different component that forming, or different minerals forming these particles. Now, if you just take a simple example and you compare pure sand particles, as you see in the picture, and pure clay particles. Now you have sandy soil and you have clay soil. Look at the sandy soil. The sandy soil, you have bigger size particles, and therefore you have bigger spaces between them. However, the mass of each particle is heavier compared to clay. Why? Because most of the sands consist of quartz, which is heavy. Now when you go to the clay, you find it's only the particles are very small, and you have more spaces between them, and you have also less quartz on it. It's mostly other type of minerals. That's why it is lighter. That's why the bulk density of the sandy soil can be up to 1.5, whereas for clay it can be up to 1.2 something. So you see the differences between them now. And that's why, for example, when you look at the loam soil, it would have a bulk density from 1.1 to 1.4 because it has a combination of sand, silt, and clay, as you remember from the soil triangle. Now, even with these two things, even with the example of the loamy soil, you still find range 1.1 to 1.4. Why? It's the same. You're using particles. What can make the differences? Remember something again. In your soil, you have pore spaces, organic matter, water, and many other things. And all of these things can affect the bulk density. Now, arrangement of the structure of the particles itself. The arrangement itself can different. When you have it like this, if you just look at the sand particles example, when you have them like this, then you have a particular spaces between them. Then when you compact them and to make the same volume, then the mass increases. That's why it is affected by the arrangement of the structure. And it's also affected by the cultural practices. Now, if you, for example, plow the soil, you make more spaces between the particles. If you add more organic matter, you are adding lighter materials to the soil. If you add more water, you are making it heavier. And that's why the bulk density can vary depending on the practices that you are doing. Let's take this final example to ensure that you got the idea of the difference between particle density and the bulk density. Now imagine you have again a cube and you are using the same cube to measure the bulk density and the particle density. And the cube has a certain surface area, you multiply it times the number of faces, this times 6, and you got the volume, which is 1 centimeter cube. Now again, for the particle density, you are measuring the mass over this volume. So the mass would be only considering the mass of the solids, only the solids, without the air, without the water, without the organic matter, only solid, 100% solid. You put them all together, compress them, ought to occupy entirely the full cube, and then you weigh them, and you got the mass 2.66 gram. Now, to get the particle density, divide just 2.66, the mass over the volume, and that would be 2.66 gram per centimeter cube. Now, use the same volume to measure the bulk density, and keep in mind that the bulk density includes the pore spaces and the organic matter. So when you put everything together, you got, let's say, 50% solid and 50% pore spaces, and the mass was 1.33 grams. So your density will be 1.33 gram divided by 1 centimeter cube, and that would be 1.33 gram per centimeter cube. Now, you see how the difference is? The only difference between them that when you deal with particle density, you are only dealing with the particles. When you deal with the bulk density, you are dealing with the soil as a whole. That's why the bulk density can be affected by compression, can be affected by the addition of organic matter, can be affected by anything that affect the pore spaces. Now, how you measure the bulk density in the field? Well, it's very simple. What you need to do is to get a well-known volume and then to measure the mass. So usually they use something called soil bulk density sampler, which is having something like you see and having a cylinder. Then you insert it into the soil, and then you know the volume, and then you weigh the mass and you get it. Now, to get this idea very clear, let's watch the following video in the next.
In order to measure bulk density, the first step is to collect a soil core. This can be difficult in winter. After the core has been collected, remove a soil-filled ring from the core sampler and use a knife to flatten the edges. Weigh an empty soil tin and record its mass. Empty the ring of soil into the tin, making sure to get all of the soil from the edges of the ring. Place the tin in a 105-degree oven for 24 hours in order to dry the soil. After drying, weigh the tin and record the mass. In order to calculate the dry weight of the soil, take the weight of the tin filled with dry soil and subtract the empty weight of the tin. Record the soil weight in grams. Use a caliper or ruler to measure the inside diameter and the height of the ring. Use pi r squared to find the cross-sectional area of the ring and multiply that value by the height of the ring to get the soil volume. Record this volume in centimeters cubed. To calculate the bulk density, simply divide the dry mass of the soil by the volume of the soil.
Okay, after watching this example, I want you now to think. If you have two different soils, one soil is basically an area where you have it without vegetation, and the other soil you have basically the other area you have a soil with a lot of organic matter, you have also vegetation. Now, which one you might think have a higher bulk density? You're just using the same technique. Think about it for a while. All right, I think you would arrive to the conclusion that this soil which you take from the field with organic matter and vegetation would have higher or lower? Think. All right, would have a lower bulk density compared to the one with with the bare soil. Why? Because you are using the same volume, you are using the same instrument, but then in the soil with organic matter, part of that volume of the cylinder will be occupied by the organic matter and by the roots. Those have a lighter mass and therefore more spaces, more pore spaces, and therefore they will have, at the end of the day, lower bulk density. They will lower the bulk density. Now, if you add water if you have now comparing two fields, the same soil, sandy soil, one is irrigated with water and another one is fully dry, which one would have a higher bulk density again? Of course, the one with irrigated. Why? Because you are adding even water to the pore spaces, and remember, the mass of air is neglected. So water mass is higher, and therefore you would have a higher bulk density. Now, let's see what is the relationship between bulk density and the pore spaces. What is going to happen? So to get the idea very clear, you have three different pictures. Look at the particles, how they are sorted and organized, and think which one of them might have a higher bulk density and how the pore spaces would affect the bulk density. Now, if you look at the first picture, you have particles which are rounded in shape, perfectly rounded, and they are sorted nicely like this. However, when you compress these particles, you compact them, work on them, compacted them, then the spaces between the particles will be a little bit like occupied, and by that you have to fill the same volume, and then you ended up with less pore spaces. And that would, what does it do with the bulk density? Now think about it. Now in the third case, you have a combination between the rounded particles and also with smaller particles. And in this case, you would see that the space even is more occupied. Why? Because the spaces between the larger particles are occupied and filled with the small particles. So in this case, that you have more particles in the third scenario. And these particles, let's assume that the big particles are sand particles, which you know are cores, and cores are heavy. And then even in the spaces there, you have another, like, let's say, fine sand. Now, what will happen to the bulk density? Basically, it's going to be increased. So we can see that the space and the bulk density are inversely related. The more the spaces you have in the soil, the less the bulk density will be, because these bases would affect the mass, and remember, bulk density is mass over volume. Another important point that I want you to keep in mind, that different types of soil, of textural classes soil, would have a different values of bulk density. So if you compare a sandy soil with a clay soil, you would find that the sandy soil would have a higher bulk density because sand are made of mostly like the quartz, and quartz are very heavy, you know them. And if you compare it to clay soil is mostly like smaller in particles, much smaller, and therefore you have more spaces, more pores there. And not only that, the type of minerals in the clay soil, usually secondary types of minerals, and it's not quartz. That's why those are light minerals. That's why the mass of clay would be much lower than the mass of sand soil, and therefore you will end up with a lower bulk density for clay soil. Another thing that to keep in mind, that if you just compare the normal condition, if you compare sandy soil with the silt and clay, as you see in the mid picture here, and you compare the water movement between them, you would see that the clay soil have a lower water movement, that water like takes a lot of time to get into the soil because of the small pore spaces. Compare it to a sandy soil where just like once you put the water, it just like goes down. Now imagine that if you added compaction. Now which one is more compacted? Is it sandy soil or the clay soil? Of course the clay soil, as you remember from the previous lecture, its properties makes it very compactable, like it's more prone to compaction. And imagine that you increase the compaction, now you compacted these soils, it means that you further reduce the water movement into the soil. Something else to keep in mind, that the bulk density, although it tells us about the condition of the soil and the pore space in the soil, but it's not a good indication for the suitability of the soil for the plant. It's not the whole story. Why? If you look at the last picture, you would see that in a normal condition without compaction, the roots can go nicely into the soil comfortably and can go deeper to tap the water and the nutrient. In a compacted soil, the roots won't be easily penetrating the soil, and that makes it really hard for them and makes it suffering for them. However, this tells us about the condition of the pore spaces, but keep in mind that the plants need other things, like the nutrient, needs the water, needs the proper temperature, diversity of microorganisms, and so many other factors. That's why bulk density alone is not the whole story. You need other things to tell whether the soil is good for agriculture or not. After looking at the relationship between bulk density and pore spaces, we found that it is inversely proportional, that if the pores increase, the bulk density decreases. However, still a lot of you might ask themselves the question, that is really bulk density important for the pore space or porosity? Now I mentioned here porosity. What do we mean by porosity, and what is the difference between pore space and porosity? To get the idea of that, let's look at the picture here at the middle. Now if you want to compare the pore space between sand, silt and clay, what you can observe? We mean by the pore space the space between each particle to another. And you would see from this example that clay would have less pore space because the particles are small. But when we talk about porosity, we mean something else. We mean the total amount of pores exist in a particular volume of soil. The whole pores, we sum up all the pores. Or let's say the ratio of pore spaces to the solid. Now, if we use the same example, sand, silt and clay, which one of them might you think that would have more porosity or higher total volume of, or higher volume of pores compared to the solid? Think about it for a moment. Alright, you would see that when the particle size becomes smaller, the the amount of pores in that soil will become more and more and more and more. And by this, the porosity of that soil will become more and more. So clay soil have more porosity than the sandy soil. However, sand soil have more pore space, the space between each particle to another, larger space compared to the clay because of the size. So that's why porosity is also very important concept in the soil. And the porosity usually in the soil ranges between 30% to 60%. We express it in percentage. Why? Because the porosity only happens in the pore spaces. We are talking about the pore spaces. We're not talking about the solid. We're only talking about the pore spaces which can be occupied with water or with air. So if you have a soil that is more of clay, then you would have less volume of solid compared to the volume of pore spaces. Compare with a sandy soil. In a sandy soil you have larger particles, and that would make more volume or mass of solids compared to the volume of the pore spaces. Now, if you want to say that, is this information describes the arrangement or the distribution of the particles in the soil, like the previous example that we used when we said that you have compressed the soil and then you have small pore spaces between the particles? Actually, the porosity does not tell us that. Why? Because the porosity again just describe for us how much volume of pores you have in this volume of the soil. So it doesn't tell us the arrangement. The arrangement, we have to look at the soil and look how the particles are arranged. Now, how can you calculate the porosity using equation? Very easy. The porosity can be indicated as F, so it can be expressed as we said, it's the volume of the pore space divided by the total volume of the soil. And you know that the volume of the pore space only include the volume of water and the volume of air, and the total volume is basically the summation of volume of solid, water, and air. Or you can use another equation, which actually is this one. So the porosity can be 1 minus dB, which is the bulk density, divided by dP, which is the particle density. Or you can use 1 minus Vs over Vt, and that would give you the porosity. So you can calculate the porosity by these three equations. But most of the time we would use this equation, which is the porosity is equal to 1 minus bulk density divided by particle density. But you have more options depending on the givings that you have in the question. And we usually can approximate the particle density to be constant, to be 2.65. So if you have any question with calculation and the particle density is not given in that question, then you should memorize this 2.65 gram per centimeter cube and use it to solve.
All right, guys, I hope that you enjoyed the class, and now I would leave you with some of the ideas that would incorporate the things that you learn about soil into a beautiful design to make your home garden alive. So enjoy and take care. Bye.
Welcome back, viewers. Welcome to our channel, Gardening Mantra. Today we've got amazing modern front yard garden design ideas. A well thought out and organized yard style and landscaping ought to complement the natural terrain of the land and enhance the overall theme of the house. When planning your yard landscaping, it is best to consider the amount of work and effort you are willing to invest into it to maintain the surroundings. The modern look contains of fresh lines, earth colors, creative use of stone, and minimized use of divergent colors. Here are our favorite front yard designs. A garden is one amongst two things, a stunning paradise or a hell of unfinished jobs. If you don't live and breathe trowels and bedding plants, it is usually the latter. There are lots of ways in which to offer your garden an instant raise while not having to decision during a gardener for a few exhausting landscaping. We've brought along our favorite summer buys, quick tips, and easy garden ideas that will spruce up your space. And most can be done in the time it takes to mow the lawn. Have you considered revamping your yard, however, don't wish to interrupt the bank? There are such a big amount of nice concepts out there that don't value a lot of cash at all. Whether it's a landscaping area that needs a little fixer-upper or a whole outdoor concept you'd like to start, so much can be done with a little ingenuity and inventiveness. We've compiled an inventory of low-cost landscaping concepts that may not solely be fun to begin, but will also look absolutely amazing. Get the entire family in on the fun to make a stunning house everybody will appreciate. Keep reading for a few nice yard landscaping concepts on a budget. Here we have garden landscaping ideas. Let's check out. These landscaping ideas can add interest to your lawn and boost your curb appeal. Use these tips to create a timeless landscape that is easy to maintain and great to look at. Just like you should plant grass that is specific to your region, pick native plants for less upkeep. By choosing plants that are native or grow well in a specific zone or area, that will keep water and pruning prices down, and the plants will thrive. Incorporating pots into landscaping makes a yard not only more low maintenance, but also more versatile. Potted plants are an easy way to add color to different parts of a yard, and they are mobile. For an added pop of color, coordinate the flowers to the season. Try whites and pinks in the spring and summer, switch to yellows and reds in the fall.